Right, reversible debugging, or time travel debugging, as I think most people are calling it these days. So there's different ways to do time travel debugging, but basically what it means is I want to go back and see what happened. Right, when I'm debugging, the question is, how did that happen? Usually, right? I want to see I want to understand what did my program really do, as opposed to what I expected it was going to do. GDB has inbuilt time travel reversible debugging. It is very slow, but it does work. And if you're just recording a small amount of code, it can be very useful. There is a thing on newer Intel CPUs of record btrace, which will use, if the CPU and the operating system supports it, will use the what's it called? The Intel.
It will come back to me.
Yeah, there's some Intel functionality. They'll just like record all of the branches that your program makes. I keep wanting to say ptrace, but it's not ptrace.
No, it's not ptrace.
Yes. Anyways.
I don't want to say p-keys, but it's not p-keys.
It's not p-keys. One of those. And we'll figure it out. And that goes nice and fast. But it doesn't do anything. It only captures where your program has been. So you can reverse next. You can go back to previous lines. You can see the control flow, but you can't see any data. And so useful in some situations, not so good in others. There's a thing called RR, stands for record and replay. That is also nice and fast, not quite as fast as using the Intel tracing stuff, but it's pretty fast. Much faster than the inbuilt but reversible debugging. But it does depend on features from the platform. Particularly, it needs to have access to the performance counters, which may or may not be there. And there are certain kinds of programs that it can't debug, like those that use shared memory or async I/O. But on where it works very well. Or you can use Live Recorder, which does everything. But we're not going to talk about that. But what I am going to show you is the inbuilt time travel debugging from GDB, because it's kind of cool. So I have a program here called sort, which doesn't appear to do anything, but this is the source. And what it does is gets an array of 32 items, fills them with random stuff, and then goes and sorts it, and doesn't print anything, just does that. But I happen to know, if I run this again and again and again, like that, enough times, eventually, the watched pot will boil.
Greg's brave because he uses genuine randomness in his presentations, which I'm usually too scared to use.
Like brave or stupid?
I mean, I was expecting it to crash. You haven't fixed the problem, have you, Greg?
No, I definitely haven't fixed it. I don't fix things. Hey, look, it segfaulted in the end. So we've all had these kind of bugs, right? Take a long time, you have to run it a whole bunch of time. Yeah, you can reproduce it, but how do I get to the bottom of it? Well, I've got a core dump, so let's have a look at the core dump. So that's my core dump there. So I can go gdb-c, so let's look at the core dump. Terminated with the segv, that looks right. Terminated at question mark, backtrace, sad. So I seem to have a broken stack, which is probably why it's segv'd, and I've got no idea what my program did. So that is that's a completely unhelpful core file. So let's run this now in GDB. Oops. And remember, I have to run it a whole bunch of times. So I'm going to start hooking together some of the commands that we've seen. So I'm going to put a breakpoint on main, and I'm going to run to that breakpoint. I'm going to put a breakpoint on exit. That's breakpoint 2. Now I'm going to hang some commands off of breakpoint 1. So commands 1. So if I could commands 1, that now tells me I can type some commands that will issue to GDB every time it hits breakpoint 1. And the first one is record, to turn on recording, and the next one is continue. And I'm going to put some commands on breakpoint 2 on exit, which is just to rerun it, right? Now, of course, this is why we need to set confirm off, because everyone at rerun it will say, do you really want to rerun? I'm going to put pagination off as well, and I'm going to continue. And so this is just sort of ping-ponging between every time it gets to exit, it's going to rerun it. You can see it's kind of slow, but this is a very small program, so it's okay. And oh, it failed quite quickly that time. So if I have a look at my backtrace, yeah, same as before, that was like my core file. But now what I can do is, if I go reverse, well, let's just look, actually, look at the program counter. So program counter is that. So if I X to examine the memory of that address, yeah, that's not a valid address. So I've branched to hyperspace. This looks like, classic stack corruption. Reverse step I, like step I, step one instruction, but we're going to step back one instruction, which we can do because I enabled the recording at the start of main. So reverse step I, ooh, look, let's go control XA. So I'm at the return of my program, which if I've smashed my stack, I guess makes sense. So let's have a look at the stack pointer. So stack pointer is that. So if I examine memory there, yeah, that's that bad address that I was at. So because then on x86, when I do a return instruction, actually let's look at the machine code. So we are here. So when I do a ret instruction in x86, I'm going to return to whatever the stack pointer is pointing to. It's a full descending stack, and that appears to be garbage. So unfortunately, you can't put, I think, or if I remember correctly, watch -l sp, that won't work. Doesn't like it. I don't want to do watch $sp because that will set a software breakpoint, and we already discussed those are not very, well, yeah, they're very, very slow. So I'm just going to do this the sad way, watch star, void star star, that. Oh, why didn't that work? Okay. Maybe I can go like that. Hopefully that will work. Info break will tell me what watch points are set. Watch point, I don't think that's going to do what I want. Why can't I copy paste that address?
That seems disappointing.
Yeah, this was happening. Let's see if this works. Reverse continue. Yeah. Let's go back to, it did. Okay, that did what I wanted. Right, so I've watched that address, I've watched top of the stack, I've gone reverse continue, so it's gone back in time until the watch point is triggered, right? So I want to know why did that stack get corrupted? This is a line of code that most recently wrote to the stack. So this is usually very powerful. So we're writing to the ith entry of the array, print I is 35. If I say what is array, it will tell me that array is an array of 32 longs. So I've written outside the array. Why have I done that? Oh, well, look, I've gone % size of array. And of course, I wanted to modulo the number of elements in the array, not the number of bytes of the array. So we wrote past the end of the array, and that corrupted my stack. So there's a little demo with a few super cool features and how we can do some time travel debugging to find out what happened.